So here we will solve another example of double integral. So again here the order of integration is not given to us and we have to evaluate it over the journal region. Don't get scared by looking at the variable s and t, it's fine. Now s varies from 0 to 1, so limits of s are constants, whereas t varies from 0 to s power 2. So the order of integration should be dt ds. I hope this is clear as I explained it in my previous video. So how we will write the question? This question will become cos s power 3 dt ds. Limit of t is from 0 to s power 2 and limit of s varies from 0 to 1. So when we start solving it, we have to start with the inner integral. Okay, now when you look at the inner integral, what you can see? You have to integrate this integral first, which is integration with respect to t. So let's write it down. So it is integral 0 to s power 2 cosine of s power 3 dt. Now you may think that how to integrate cosine s power 3, because you have rule only for cos x, right? What is the rule? We have the rule that cosine of ax plus b, its integral is sine ax plus b over a plus c, right? But remember, this rule is working only for x is equal to 1. What will happen if our variable becomes here s? Nothing. The rule will change. In place of x, you will have s. So the rule work exactly same. But here the thing is that power of s should be 1. But what we have? Power of s as 3. Still, you don't need to worry, because if you remember the rule of integration here, when we are working with two variables, here we are integrating with respect to variable t due to dt. So the other variable, which is s in this case, will be constant. So it means basically this entire term is constant. So our integral will become cosine s power 3, and you are just integrating the term 0 to s square dt, right? Now what is the integral of this? Its integral is cosine s power 3 times t. Integral of t is same as integral of 1 dt. So it will become this one, and limit of t varies from 0 to s square. So if you don't remember in this way, if you do not understand it in this way, what you can do, you can follow the other way that I explained. Cosine of s power 3, you are integrating with respect to t and there is no t term, so you multiply by t. Okay, so let's complete it. So it gives you cosine s power 3 times, once you replace t by s square, and then you have to replace t by 0. So 0 multiply anything will become 0. So you left with just this term. Now here don't do mistake of multiplying s with a square. This is wrong, because this is an angle. These are the boundaries. Nothing can go inside the boundaries, neither we can take outside anything. So it's better if you write it in this way: s square cosine s power 3. So what we see, the first integral which we integrated with respect to t, here we have no t term. So it means what we did is correct. So let's go back to the original integral. Now we left with this integral 0 to 1. Now in place of this bracket, we are using this value of integral, which is s power 2 cos of s power 3, and then what we left with ds. Okay, now what you can see, this integral is product of two terms, s power 2 and cosine s power 3. For s power 2, you have direct rule of integration. If you look at cosine s power 3, but you can use this rule of integration only when the power of s is 1. So for this function, the direct rule of integration is not available. So it means you have to integrate it by substitution. Okay. So now as this term s power 3 is creating the problem to use this rule, we take this as u. So once we use this as u is equal to s power 3. The next term in method of integration by substitution is find the derivative. Now here we will find derivative with respect to s because of ds. The purpose of doing this is we have to replace the whole variables s by u. So we should replace ds as well. So what is derivative of u with respect to s? By using power rule, 3s power 2. This gives you the value of ds as du over 3. So it will give you the value of ds as du over 3s square. Now we substitute this value of u and this value of ds in the integral. So this will become, this is ds, okay, this value. So what it will become? Integral. Let's not write the limits here because limits are for s and we are changing to u, so the limit will change. So we will write down the limits after getting the final answer in terms of s. So s square, we keep it same as we are not changing. Cosine of, in place of s power 3, what we are writing? In place of s power 3, we are using u. So let's replace it by u. And in place of ds, we have a new value, du over 3s power 2. So now we can see here we have two variables s and u. So it's always better to simplify. So we simplify it. So what it will give you? Integral of, now here in the denominator we have a number 3. In numerator nothing. So we take it outside as a constant 1 over 3 because 3 is in the denominator. Cosine of u du. Now we can use this rule here. So this gives you integration of cosine gives you sine. Sine of u and okay, so this is equal to 1 over 3. Now we will not substitute the value of u here from 0 to 1 because these are the values for s. So we should replace back u by s power 3. So our answer is sine s power 3. Now here the limits of s varies from 0 to 1. So this gives you 1 over 3 sine of, when we replace this s by 1, we get 1 power 3 minus 1 over 3 sine of 0 power 3. Sine of 0 is 0, so this total term becomes 0. So the final answer is 1 over 3 sine of 1. So you should see that the final answer should be a constant always. If you are getting a variable here, it means you made a mistake somewhere.